The results from the alpha scattering experiments were not consistent with the model in which the mass and the positive charge are uniformly distributed throughout the volume of the atom. Instead, the results suggested that most of the atom must be an empty space, in which the mass and the charge of the atom are concentrated in a very tiny fraction, as we see here. So this tiny fraction is composed of the whole mass of the atom and its charge. And this tiny fraction is called the nucleus. This suggestion is illustrated by this figure. So here we have the most of the atom, which is an empty space. And we have here the negatively charged particles that are the electrons, as we see here, and this tiny fraction, this dense central core within the atom, which is the nucleus. This model, proposed in 1911 after the alpha scattering experiments, could better explain the alpha scattering experiments. So we see here this figure that is an example of the tin gold foil, and here we have these atoms as modelized by the empty space. So here this empty space would allow most to the alpha particles to pass through the tin gold foil. And the ones that were largely deflected, it was due, like this one, or this one, it was due to their collision with the nucleus in either glancing fashion. Because the nucleus is positively charged and the alpha particles also were positively charged, so a larger portion resulted from their collision. And the ones that were reflected back at the source, because they traveled directly toward the nucleus, so they experienced the most important repulsion from the nucleus.